Hey guys, let's discuss new topic which is CI/CD for AI systems. So you can go to playlist section and then you can see all the playlist what I have created on data structure, system design, AI system design, and AI Gen AI related all the topics. Okay, so now here in CI/CD for AI system, see CI/CD for AI system means automatically building, testing, validating, deploying AI models, okay, safely and continuously. So, you know, in traditional coding, traditional deployment, let's say web application, so we were doing code changes and then we were deploying it on the server, right? And then we were building it, then doing integration testing, validating it, and then we were deploying it. Here also we are doing the same thing, but there you were just doing code deployment, okay, code changes, so you were deploying that code. But here instead of code deployment you have lots of things. So for example, see, traditional software CI/CD handles code deployment, but AI CI/CD handles models, datasets, embeddings, prompts, and GPU inference. Okay, so let's say you have not done any code changes for your model, but instead of that, if you do the next version deployment, definitely the lots of things will change. Okay, so for example, earlier you have given different prompt. You have given prompt that answer user in a you can say in a bullet points. Okay, now you have changed that prompt and you have changed it to response user in a paragraph way. Okay, that is the one thing. Second, earlier you have trained your model on 1 lakh document, let's say, and now after 1 month you have trained your model on 10 lakh documents, let's say. Okay, you have not done any data change here, but you have not done any code changes here, but data has been changed here, right? So data set changed, and then embeddings changed, let's say. Okay, you have yeah, so like embeddings is text into vector, right? So new documents you will upload, so new embeddings will come here. So now your response will be more accurate, right? There will be a data drift also, so your prompt will get changed, GPU inference will get changed, so lots of things will get changed. That's why AI CI/CD is little bit hard. Okay, so now just as DevOps help developer to deploy software reliably, MLOps help data scientists and ML engineers to deploy AI ML model reliably. AI CI/CD additionally handles model, dataset, embeddings, prompts, and GPU inference. So the same thing. Okay. Now we will see that what is difference here. Okay. So I already explained you the difference, but see why AI CI/CD is different. Okay. So in normal apps, just code will get changed, but in AI systems, model changes, prompt changes, data changes, and embedding changes. Okay. So even a small change can reduce your accuracy. Okay, let's say it was working fine and now there will be a lot of bug, let's say, and then increase hallucinations. Okay, means AI will give answer, he will invent the answer and then give you the answer, then break production behavior. So traditional application CI/CD, in a normal application, the deployment pipeline mainly focuses on code changes. For example, earlier the code was something like this: you are assigning value to discount variable. Then let's say you have changed the value in discount variable, and the pipeline. Okay, what will be the pipeline here? Now you will build the application, you will run unit test. Okay, and then you will run integration test, and then you will deploy it. Okay, so here the output predicts behavior because behavior is determined by code, right? But now, why AI CI/CD is different? Okay, so in AI systems, see, in AI systems, behavior can change even when application code remains exactly the same. AI system have multiple moving parts. Like first one is model change. Okay, let's say your model gets changed. In that case, suppose your chatbot uses language model before model version v1, but after your changes it is using version model v2. Okay, we are using the model which we are requesting the question, right? So no code change, but your model version has been changed. So now, but response may become more accurate, less accurate, faster, slower, or more expensive. Okay, according to that new model. And for example, user was asking initially explain Kafka. Okay, so model v1 were giving short answer, but now model v2 will give the detailed answer with example. So same code but different behavior you can see here, right? Second one, so first one was model change, second one is prompt change. Okay, so like prompt, initially you have given instruction given to the AI model, okay, something like this. So prompt v1 will give that answer in one sentence, but prompt v2 will now change and then will give answer in detailed bullet points with examples. Okay, so for example, no code changes here, but output change completely. For example, user asked what is Kubernetes, so v1 were answering in one line. Okay, like Kubernetes is a container orchestration platform, but now v2 will answer in a bullet points, okay, and more detailed way. So like it will give in bullet points like automate deployment, handle scaling, manage container. Okay, so it's a small prompt modification can have a huge impact on AI behavior. What prompt modification you did? You just changed this one, that answer in one sentence to answer in detailed bullet points with example. Okay, but they see the answer, the response has been changed dramatically. Okay, so this is the second thing. So here prompt can also change even though you are not doing data changes or code changes. Okay, and earlier we were doing code changes. So third one is data changes. Okay, first one was model, second was prompt, third is data changes. So now for ML training system, data is often important than code, right? So example, model trained on 1 lakh customer records, next one 10 lakh customer records. Okay, so code is unchanged, but model prediction may improve or degrade, okay, according to the new data. So common issues, data drift, okay, changes in data, then difference in data, and then missing values, wrong label, or biased data. So therefore AI pipeline must validate data quality before deployment. Okay, so now the fourth one is embedding changes. So embeddings are vector representation of text used in RAG system, semantic search, AI assistant, and knowledge base. Okay, so for example, document was like this: Kafka is distributed streaming platform. So this is plain text. Okay, and embedding model we were generating the equivalent vector for this is this one. Okay, and v2 was generating this. So you can see the difference in a generated embeddings, right? So application code remains unchanged, but search result may become completely different because see the numbers are different now. Here it was 0.12, this is 0.67, right? Different numbers. So for example, user searches message queue. Okay, yesterday Kafka document appeared, today RabbitMQ document will appear. Okay, two types of MQ, Kafka and RabbitMQ, right? So because embeddings changed, so the document you will get the different one. So high level AI CI/CD pipeline, if we talk about, so what is the high level architecture for this? See, code or data get changed. Okay, so CI pipeline, and then it will go to model training or fine tuning. Okay, after that we will evaluate it and validate it because it is very important. We have seen why. Okay, now it will build a Docker image. After that it will deploy to staging. Okay, we will do some testing there, let's say Canary testing. We will see what is Canary testing here. Then production deployment. Okay, so now main component, let's talk about 15 main components of this system. So first one is source control. Okay, so store application code, prompts, config, and model metadata usually in GitHub and GitLab. Okay, so this is just the your source control like repository. And then data versioning. So very important in AI, need versioning for training data sets. Okay, and then embeddings, feature sets. So now why? Because model quality depends heavily on data. We have seen that data is more important than code here. For example, dataset v1 and dataset version 2. Now third one is model training pipeline. Okay, so after data or code changes, trigger model training, right? So because new data came, so now you have to train your model according to new data, right? So could include your fine tuning and then embedding generations and then retraining. Okay, training and fine tuning, two different things. Training means you are giving the model to a knowledge, let's say. Fine tuning, you're giving the specific domain knowledge. Okay, so you're changing the behavior of the model there. So often runs on GPU cluster and distributed training systems. Okay, after model training pipeline, automated testing will come into the picture, right? Because we cannot test manually. So AI system need more more than unit testings. Okay, so types of AI testing, let's say we use unit testing for checking the API correctness. Okay, and then we do prompt testing to check prompt quality, hallucination testing for factual accuracy, okay, based on some facts, whether the answer is coming based on some facts or it is invented by the AI. Now safety testing, so for toxicity we use it, okay, to determine. Then for latency testing, so like for performance, okay, and then regression testing to prevent quality drop. Now for example, question was what is RAG, so expected answer is corrected factual answer, okay, should be the factual answer. Now, fifth one is model evaluation. So, what is model evaluation? Very important before deployment. So, metrics, what we will be using here is accuracy, hallucination rate, latency, and cost. For example, new model 10% faster, fewer hallucination only then deploy. Otherwise, roll back to the old model. Then sixth one is build Docker image. Okay, so package, so what all things you will package here: your model server you will package here, dependencies, CUDA libraries, and inference engine. Okay, we have seen in earlier video what is CUDA. So basically this is this will connect your application to GPU, because GPU initially was designed for graphics related task. Okay, but now here we are doing the normal task, so you would be required there CUDA libraries in between. Okay, now into containers. Now example, VLLM and LLama model you will package, okay, and create a Docker file, let's say. Now deploy to staging. Okay, so before production you have to deploy to staging, and then you will do testing, your all testing. Okay, so never deploy directly to production. First test a staging environment, validate GPU inference, and run traffic simulation. Eighth one is Canary deployment. So what is Canary deployment? Safest deployment strategy. Okay, 5% traffic goes to new model and 95% will goes to old model. Okay, do testing on 5%, and if everything looks good, then divert the remaining traffic there. So what you need to monitor when you deploy 5% traffic to the new model, when you route this 5% traffic there. So hallucination, latency, failure, and user feedback. If everything looks good, then just only divert the remaining one. Now rollback mechanism. So very important, if new model causes problem, rollback immediately. Need fast rollback support, right? 10th one is blue-green deployment. So blue-green deployment, two environments would be there, okay, blue and green. Blue will be your old environment, green will be your new environment. So you just switch the traffic safely, okay. So like for example, your current application is running on blue environment, okay, which is old one. Now you will deploy your new changes, new code, okay, to new embeddings, dataset, and everything to green one, okay. Once it is up, so just divert this traffic to this one, then green will become blue and blue will become green. Okay, we generally do this in AWS. It is easier, right? I have done that there. Now the 11th one is feature flags. So enable model gradually. Okay, example like enable GPT-4 only for premium users. So only for premium users you do this, use a flag, okay, feature flag, let's say, call it feature flag. So if it is on for those users, then just only provide that facility to those premium users. Now monitoring and observability. So monitor your latency, GPU utilization, hallucination rate, token usage, and failures. Okay, for example, example metrics we will be using here: TTFT, time to first token, so that you will check the latency, okay, and then TPS, token per second, hallucination rate, means how how your AI system is correct, okay, how much, and then GPU utilization for efficiency. Now 13th one is continuous evaluation. So AI system continuously monitored after deployment. Why? Because model quality can drift over time. So for example, new user query, okay, model accuracy decreases, so need retraining in that case. Now 14th one is prompt versioning. So prompt versioning, like model LLM apps heavily depends on prompt. So prompt template store, you need to store prompts. Like earlier you have given that answer in a one line, now you have given answer in a detailed way and in a bullet, give in a bullets, okay, bullet form. So this templates you have to store somewhere, that first you use this and now you're using this, okay. Then system prompts and then versions, all things you need to store. Now for example, prompt version 1, prompt version v2. So you will have the versioning there. Embedding pipelines. So RAG system needs embedding generation and vector DB updates. So CI/CD may include a new document, then you need to chunk those documents, okay, then you need to create an embedding, okay, from those things, and then vector DB refresh. We will store that in a vector DB and we will refresh the vector DB. So for example, AI deployment flow will be something like this. See, developer will push the code, okay, then CI, continuous integration pipeline, will run. It will run your test, it will validate the model, then it will create a Docker image. After that he will deploy it to Kubernetes, and then Canary rollout. Okay, now real technologies what we use here. Let's say for CI/CD you're using GitHub Action. Okay, for orchestration we'll be using, let's say, Kubernetes. For model serving we are using VLLM, and for monitoring we are using Prometheus. Experiment tracking we are using MLflow, let's say, and then data versioning we are using DVC. So challenges, what challenges you will be facing here? See, the problem is hallucination. Okay, so what would be the solution for that? You have to run evaluation test. If it's slow GPU deployment, then rolling upgrades. Okay, model drift, so continuous retraining. Okay, model drift means the performance has been decreased after new deployment, so retrain your model again. Bad releases, so Canary deployment, okay, 5% traffic, then 95% rollback. Huge model, then efficient containers you would be required. Okay, so a rolling upgrade is a deployment strategy where replace old version v1 with new version v2 gradually instead all at once. So that's it. Thank you.